My name's Ryan Baxter, and I am a developer advocate for Bluemix at IBM. If you don't know what Bluemix is, you should come and check out our booth. But I won't really talk too much about it today. You'll see it a little bit, but the presentation's a general topic, not really a product pitch, so that's good. You can follow me on Twitter. I'm a huge Twitter user. I love all my Twitter followers. At Ryan J. Baxter is my Twitter handle. I also blog pretty often as well. You can check out my blog at ryanjbaxter.com. And yeah, so today's talk is going to be about microservices. It's going to give you a quick introduction to microservices, what they are. I hope everyone is interested. Everyone wants to know what microservices are, right? Okay. Is anyone here building applications for the cloud? Yeah? Okay. Anyone interested in building applications for the cloud? They're trying to. They're thinking about doing it. All right. Cool. So it's all good stuff. We'll cover a lot of these topics today. So before we talk really about what microservices are and why you should be building your applications using this architecture, we need to take a step back and think about where we've come from over the past few years. So I think we're all developers, right? Everyone a developer here, right? Mostly? Come on, I thought most of the hands were going to go up there. We're all developers here, and I think we all realize that we're under a huge amount of pressure to deliver things with more and more speed, right? The faster we can get the code out there, the faster we can get it into our customers' hands, the faster or the happier our managers and executives are, right? And it wasn't too long ago that we were practicing something called Waterfall Development, right? Who here did Waterfall Development? Okay, right? We have these extremely long release cycles, right? And we'd shove all this code, these features, these bug fixes into the release. And then after a year or even more, we'd cut the release and we'd give it to our customers. Well, the problem with that model was that we couldn't respond to the needs of the business fast enough, right? So if I had a new potential sale and they just wanted us to tweak this one thing about our product, well, we had to wait a year for the release to come out, right? And that wasn't quick, right? So we came up with a new way of developing software called Agile, right? Who's practicing Agile software development? All right. Who thinks they're doing it wrong? Okay, cool. Yeah, that's what everyone says, right? So we'll talk about the theory behind Agile development. I know it's not always the same in practice, but in theory, with Agile software, the idea was you have this iteration and you'd do bug fixes and implement features during this iteration. At the end of that iteration, the code would be in a state where you could do a release if you needed to. So if the business decided that, hey, it was time to do a release, we need to satisfy these customer needs, let's go ahead and do it. We can do it when we need to. Now, these iterations kind of just an opaque term, right? Who knew what the length of the iteration should be? Some people do a month, some people do 2 weeks, some people do 1 week. But the idea is that it's shorter than a year, I think. We're supposed to be able to get the software out there a lot quicker. Now we even see kind of taking this to an extreme, right? There's some companies out here that are really good at Agile development and do releases to production multiple times a day, right? The Facebooks of the world, the Amazons, the Netflix of the world, they're able to do releases and they release code into production every single day, multiple times a day, right? So some people have mastered it, other people not so much. But when we were done, we were ready to do our release, what would happen? Well, we cut the release, we do the build, and then we give it to our ops team. But then, they'd run into problems, right? So everything worked fine in development, right? It was great, this code is rock solid, there's nothing's gonna go wrong, and you hand it to the ops team and it blows up in their face, right? And then you'd spend all this time trying to figure out what's going wrong. So we were able to produce the releases a lot faster, but the ops team wasn't able to deploy them fast enough, right? Which is a problem. So then someone came up with this thing called DevOps, right? Where DevOps was all about development and operations working together, right? And so if it came time to do the release and operations was to go to deployment, there was someone there from development to help them if anything went wrong, right? So they could fix problems. And even in some cases, developers are doing the releases now, right? Developers are responsible for doing it. So we've eliminated the problem, or tried to eliminate the problem of handing this thing over to operations and it going completely kablooey, right? But sometimes when you go and do a release of a new piece of software, or make some changes to your application, it requires that you change some part of your infrastructure, right? Maybe you need to upgrade a machine or add more memory, or you need some networking changes or whatever, right? So the process there, especially in big companies like IBM, I know this process all too well. You go to your IT department, you say, I need to make these changes, and they say, okay, we'll get to them as soon as we can, submit a ticket, and as soon as we can to them means a month or longer, right? There's all this process in front of making these infrastructure changes, right? And for good reason sometimes, but it's frustrating as a developer, right? Because you're ready to deploy the software, you want to get it out there, and I don't want to wait for a networking change that should take them 5 minutes. It's going to take a month to do, okay? So we needed a better solution to that, because now this is slowing down our release process, right? We can't get the software out fast enough because IT is just moving too slow. Then the cloud came along and made everything better, right? It made infrastructure easy because I could go to the cloud and say, hey, I need a VM, and it needs to have this operating system on it. It needs to have this much memory, it needs to have these CPUs, it needs to have this networking configuration, and I can get that back to me in about a couple of minutes, right? And that could be a public cloud, it could be a private cloud, but it doesn't really matter. But this thing called the cloud just made these types of things a lot easier, which is really nice. So now we've eliminated all the bottlenecks, right? We've changed the way we're doing development, we've changed how we're doing our deployments, we've optimized our infrastructure by using the cloud, and we're ready to run our apps in the cloud. But our apps were never built to run in the cloud, right? So we got our apps there, and they run, right? They start up and they work for a little bit, but then we see these weird problems, right? Things go wrong that we didn't see going wrong before. So what's different? Why are we having these problems in the cloud? Well, I think one of the biggest problems is that the infrastructure is no longer in our control, right? There's this cloud, this mystical cloud thing, right? And your app's running in someone's data center. This is especially true if you're using public clouds, right? It's not under your control. And what happens on that infrastructure, or what that data center provider or that cloud provider chooses to do, is completely up to them, and you have no say in it, right? They can move your app around from one rack to the next. They can, upgrade the rack that your app's running on. They can make networking changes. They may have issues, right? They're going to have issues. There's going to be problems with their infrastructure, and it's completely out of your control. It's up to them to go and fix it, right? This just happened to me this weekend, right? IBM's infrastructure as a service is called SoftLayer, and they were rolling out these security updates throughout their data centers. And I had gotten emails about it, but like a good developer, I ignored those emails. And I went to go use my app, and it wasn't working. And I was like, what the heck's going on? And eventually I figured out that they were rolling out these security updates. And I had no say about it, right? My app wasn't designed to handle this, right? This was something we're going to talk about. But these things happen, right? And you have no control over it. So that's one of the problems. Two, the second problem has to deal with unprecedented scale, right? I guarantee you when you started building your application, you had less users than you do now, right? Especially if you're moving your application from something that used to be your customers would deploy on-premise to something that is now a SaaS offering, right? Where anyone on the internet can go and access your application. And just there's the sheer number of users that have access to your apps and access to the internet now that you probably didn't anticipate when your application was originally built. So how did we deal with these scaling problems before? Well, we had some machine running our application. We said we needed more power, and we got a bigger and better machine, right? It had more memory, it had more processors in it, it had solid-state drives, right? It was just a badass machine. But in the cloud, it doesn't really work out very well, right? In the cloud, when you scale, you scale by adding more processors to a single machine, for example. This graph, as you can see, dictates that cost goes up and up and up pretty fast. It's cheaper to actually scale what we call scale horizontally in the cloud, right? Where you add more machines that have fewer processors and scale that way, and you get the same effect, but it's a different way of doing it. It's actually much cheaper. It looks something like this, right? I'm sure most people are familiar with it, right? You have this load balancer sitting in front of your application. You have multiple instances of your application running, and the load balancer spreads the load across all these different machines. But maybe your app was never really anticipated, being run in this manner, right? There's things you have to think about when you start doing this. The other problem is the number of devices that can now access your application, right? So obviously when you built your app, you probably thought, well, I'm gonna have it running on a desktop and a laptop, but now you have to think about tablets and mobile phones and watches and cars and Google Glass and all these weird things, right? And think about Netflix, for example, right? How many different devices can you access Netflix on, right? In my own case, I can do it on my phone, my tablet, my desktop, my laptop. My TV has an app for Netflix. My Blu-ray player has an app for Netflix. And I guarantee you that Netflix never really anticipated all these things, right? This puts a lot of extra load and stress onto your application. And you need to deal with these different platforms in different ways, right? This is another problem with your app, with running your applications in the cloud. So all this stuff requires kind of a new way of thinking and a new way of designing our apps, right? And today we build applications that are kind of referred to as monolithic applications. They're big, right? If you're a Java developer, for example, you package your entire application up into this WAR file, and you have this big giant WAR file, and this is what you deploy as your app, right? Think of it kind of like a whale, not mail, a whale. It's huge, right? It's big and gigantic. It's lunky. It's slow. It's whatever, right? It's huge, right? So it is beautiful. Yes, it is beautiful. You're like, I can't believe I accomplished this, right? How did I get so much stuff into this one WAR file? Didn't know it was possible. So yes, right. But as you can see, microservices doesn't really help in that. Well, as we'll talk about, microservices doesn't help in that fact. So there's a new type of architecture that's becoming very popular called microservices, right? In this architecture, you actually take that big thing and break it down into many, many, many small things, okay? And think of it kind of like comparing a school of fish to a whale, right? They may be the same size, but there's actually thousands or hundreds of thousands of fish in the school of fish that are very small, but are pretty much the same size. So they're very small micro apps. So everyone likes to have concrete definitions about things. So here's my not my concrete definition. It's Martin Fowler's concrete definition. If you Google Martin Fowler and you Google microservices, he's probably written the single most popular article on microservices out there. So I chose to steal his definition. And it's kind of cut off on my screen, so I'll read it from here. So in short, the microservice architectural style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms, often an HTTP resource API. So what is he basically saying there? He's basically saying that we have a single app, right? The interface the end user is using is actually composed of many small services. It's actually not just one giant app. It's many things put together. And they're not all running, in a single process. They're actually running in separate processes. They're all broken apart. And because they're running in separate processes, they need to communicate in some way, right? So typical way of doing this is HTTP, although there's other ways as well. So there is actually one thing that I think is missing from Martin's definition, and that's really your organizational structure, right? One of the profound things about building software, and this is actually, someone actually wrote a law about this called Conways Law, that is that your software reflects your organizational structure, right? I think most of us today, including me, work in an organizational structure where they have UX folks, then they have developers, and then they have testers, and they have operations people, and they have product managers, right? And they're all kind of in these separate organizations, right? You all get grouped into these things. It's important when you think about building microservices that you try to change that organizational structure, okay? Because each service should actually have its own UX person, its own developer, its own tester, its own product manager, etc., right? It's important that each service is actually treated like its own app, as we'll talk about, and that there is a group of people responsible for that app, and that includes, everything from the UX person, the product manager, to the database person, all right? So some guidelines for microservices. Unfortunately, the term micro makes everyone think of size. And granted, microservices do have something to do with size, but everyone wants to know, well, how small is small, right? How do I know if it's small enough? And you'll read articles on the internet that people say, hey, your microservices should be 100 lines of code, or they should be 1,000 lines of code, or they should only contain one class, right? And to me, this is all kind of silliness, right? Because there's no way that you could have one single definition for the right size for a microservice that works for everything, right? So while they should be small, and there's no real definition for how small, there is some kind of definition around the size of the team that works around each microservice. You'll hear the term two pizza teams often. And this basically means that the team that is working on the microservice should be able to be fed by two pizzas. If it can't be fed by two pizzas, then it's probably too big. You have too many people, and you're going to start and run into these organizational problems that are going to slow things down. You should probably think about breaking the team apart and splitting the service up. So that's kind of the definition, my definition of size. I mentioned a second ago, each service should really be treated like its own app, right? It has its own product manager. They work independently of the other services. It has its own source control repo. It has its own build pipeline, right? Everything about each service is completely independent of everything else and really should be treated like its own product or its own app. It should not require the use of other services. So this term, well, this one's a little funky. Basically what I mean by that is if you have service A and you have service B, and service A depends on service B. If service B dies, goes away, is not running, for whatever reason, service A should still work, okay? Service A should be able to start up, it should be able to accept incoming requests, it should be able to respond back to requests. Now the response that you get back might be bogus, right? It might have bad information, it might give you an error because service B isn't running or is having problems for whatever reason, but you should still be able to talk to it, right? So that's a very important part of microservices. Service owners are responsible for the entire lifecycle. There's no, okay, development built the service, now there's people over here that are going to maintain it. That's not the way this works, right? From the team that owns this microservice owns it from conception all the way till you take it out of existence, right? You kill it off. And they do everything from development to design to maintenance to testing, everything about it, okay? As we saw in Martin's definition, it's important to use lightweight protocols, all right? You're going to have many services talking to each other, and to render a single page, you're going to be talking to many different services. So it's important that these protocols you use are very lightweight, they're fast, and they're not heavy at all. It's also important that you use the right tool for the job. Pick the right database technology, pick the right language, pick the right framework. Right? You don't have to be suckered into using one specific technology for everything because you have so many different apps, right? So there's no one overarching technology that you have to use anymore. So make sure you use the right tool for the job. Each service should have its own data store. Now this is probably one of the most important rules and the most problemsome rules and contentious rules out there. So if the service needs to store data somewhere, needs to store it in a database, it should not be using a database that's used by another service. Okay? It should have its own database. Now this raises a whole bunch of problems, especially around data consistency. So you'll hear the term when you hear people talk about microservices, you'll hear people refer to eventual consistency, meaning that if you have data duplicated across multiple databases, that data may be inconsistent for some period of time, but eventually it will become consistent. And this is a hard thing to do, granted, right? It's a challenge, right? And you could probably do a whole presentation on data consistency issues. But it's important to do because it allows that service to evolve independently of everything else and not affect anything. Obviously in some cases you might not be able to do this, right? If you're talking about things around finances, right? And having a small inconsistency in finances ruins your entire life savings. That is obviously not acceptable, right? So, you have to use some logic here. Your microservices should be able to deal with failure. It's going to happen. We just talked about that with the infrastructure, right? When you're running in the cloud, failure happens. We all know that our apps, as much as we think our apps will never crash, right? We all know they do, right? Things go wrong, things go bad, and your microservices should be able to handle that. And the last one is also very important. Automate everything. Everything you possibly can needs to be automated. When you have a monolithic application, you might be able to get away with some manual steps in your deployment process because you're only deploying one app. When you have a microservices architecture, you're deploying tens, 20, hundreds of apps. And if you have manual steps in your deployment process, that's going to be very, very costly. Okay, so you need to automate everything you possibly can. So lots of people now, after you talk about what a microservice is, think this sounds a lot like SOA, or service-oriented architecture, right? And it's certainly a hot topic. People will debate to the death that microservices are just SOA, and other people say there's no way microservices are completely different from SOA. And I happen to think that they're similar. They can be thought of in the same manner. But I think the motivation behind them is a lot different, right? The motivation behind SOA was all about kind of reuse, right? We want to build these different services that we could then build applications on, and all our apps can reuse these different services. And we had these things that for communicating between them called enterprise service buses, and they had all these logic in these things. It was driven by vendors, and it was kind of weird. But if you look at what's driving a microservice architecture, it's a lot different, right? It's not about reuse, it's about speed and flexibility and dealing with failure. And one of the main differences between SOA and microservices is that you can stick a monolith in your SOA architecture, and that's okay, right? That's fine because you're just trying to reuse that monolith. But you still have all the problems that comes with that monolith. And microservices is really about eliminating all those potential problems. So that's kind of my take on that argument. I just wanted to address that first. Some benefits of microservices. So what do you get out of doing this stuff? So the code for each service is easier to understand. Who works on a monolith today? I worked on a monolith for 5 years at IBM, and the product is probably about 25 years old. I'm sorry, no, it was older than that. It's 30 years old. It's as old as I am, which is awesome. I'll never forget the day I opened a source code file, and the date at the top of it was the year I was born, and I was like, I probably should not be changing this code right now, but I did anyways. So I worked on a monolith for 5 years, and there's probably hundreds of thousands or millions of lines of code. And there is no way, even at the end of 5 years, that I had, probably even half of the knowledge of what everything was going on there. With microservices, you can bring new people on to the team for the service, or switch people around, and it's very easy to grasp what's going on within that service because the code base is so small, right? So you can onboard developers much faster, and they can get a good understanding and become productive much quicker than they were if you were working on a monolith. The small code base just means more speed, right? Everything about it, building it, importing it into your IDE, deploying it, everything about it is just faster, right? Everyone wants to move faster, and that's one of the best benefits. Each service can be deployed independently of each other, right? So, when we're working on monoliths, we get our build done, we're going to do our release, and all of a sudden, the last minute, someone finds a bug, and oh crap, we got to respin that build, so that takes a couple days, and then we got to retest this thing, and that takes even longer, right? When you're doing a deployment of a microservice architecture, you have deployments of different services happening all the time. And if something happens during the deployment of one of them, it doesn't affect any of the other ones. You can keep on deploying, keep on evolving these other ones independently of each other. One of the benefits here, if you're designing your application right, is that failures don't bring down the whole app. If you have service A, B, C, and D, and service D dies, well, service A, B, and C are still working. And hopefully that means that most of your app is actually still working as well. We touched on this other one earlier. You have technology flexibility, right? So choose the technology that works best for the service, right? So if Java works good for service A, choose Java. If Node works good for service B, choose Node. If a SQL database makes sense for service A, choose SQL, right? If a graph database makes sense in some other case, choose a graph database, right? Before, when they had these monoliths, we choose a technology when we started building it, and that was the technology we had to use throughout the entire monolith for its entire life, right? Which was terrible. And this brings me to my next point. It's easier to evolve, right? So if the technology that you chose originally was a bad choice, or there's newer versions or better things out there that you want to use, it's much easier to scrap that technology and move to the new one, right? Because the service is so small, it's well understood. You have APIs that are well defined, and hopefully you have tests around these APIs. And as long as you re-implement the same API and everything works exactly the same way, it's much easier to do that, right? When I would go to my manager and say, hey, I need to refactor this part of the monolith, he would say, no way am I letting you do that, Ryan, because there's too much risk, right? It could affect the entire rest of the application, right? Here you're isolating it to a very small portion of your app. It's well understood. So I just talked about the well-defined APIs as well. Now, I'm not saying that microservices are, the greatest thing ever. It's going to solve all your problems. There's definitely some issues with microservices. The first one has to do with complexity, and we'll see this in action in a second. Complexity because you have so many apps now, right? You have so many apps talking to each other, and you look at real large microservice architecture diagrams, and it's like mind-blowing, right? There's no way you can understand what's happening. So there's a lot of complexity. Before you were managing one app, now you're managing hundreds of apps. And deploying one feature across your microservice-based architecture involves probably touching many different microservices and coordinating between them. So that can be a little bit of a challenge as well. Obviously, the other challenge here has to do with the distributed data problem we talked about a few slides ago. Performance is also something you need to pay special attention to, right? In a monolith, you take granted that you're just making in-process calls between different parts of your app, and they're very fast and easy. In a microservices architecture, those same requests talking between different services over HTTP is a lot slower, right? You need to take into account that the performance characteristics of something with a broadband connection is not the same as the performance characteristics of something on a mobile device, okay? So that's something you really need to pay attention to. When do you make the switch to microservices, all right? I actually don't recommend that people start off building microservice applications because chances are the app, when you initially come up with it, doesn't require it, right? And you shouldn't have to deal with all these extra things. But if your app grows and grows and grows and grows, and eventually it comes to a point where you do require it, or you do need to make the move to microservices, when does that happen? When do you incur the cost? And how do you do it, right? So there's some challenges there as well. Our dev tools that we're using today are often making the assumption that we're building monolithic applications, right? Because that's what most people build. So they are optimized for that use case. They may not perform as well or be as optimal in the case where you're building microservices. Duplication of code is another thing, and not only duplication of code, but duplication of data, right? You have these disparate teams. They're kind of all building, towards this end application, but they're all working independently of each other. They're writing code, and they have their own iterations, and everything's independent of each other. So chances are that you're going to have people duplicating effort and duplicating code. Now, you'll read articles on the internet about microservices, and people say, this is great, right? It's fine, it's okay, right? But everything inside me as a developer thinks, no, right? I can't have people writing the same code. There needs to be this common library somewhere. But it's challenging to do that, right? It's hard to, even know that your teammates that are working on this other surface have written some code that probably is very similar to your code, and that you should probably extract that out. Now, if you can do it, great. I think it's okay, but the warning here is that then you need to have some communication between everyone who's using that code that you're going to make changes to it. So the team for service A can't go off and make a change to that common code without letting service B also know about it, right? Because they may break them. So The benefits to having the duplication of the code is that you can still evolve independently of each other. But when you have this common library, you need to make sure that everyone's in line. End-to-end testing is also a challenge. Before you deploy your monolith application, you go ahead and test it. Now you have to deploy hundreds of apps to test it, right? So that can be quite a bit of a challenge. If you look at some ways of dealing with this, Netflix is a good example, or maybe not the best example, but they have a unique way of doing it. Netflix is built in a microservices architecture, and they do this testing with a tool called Chaos Monkey in production, where they just go off and start killing parts of their services in production, right? Just to make sure that their application actually deal with it. I don't recommend you do that in production for everything, but that's the extreme that they take, right? And it's probably because it's impossible to do that in some kind of testing environment. But they prove that they can deal with failure, obviously. So I've done enough talking, I think. So I'd like to show a little bit of a demo. So I always like to try these things out and kind of get hands-on, get my hands dirty, especially with new architectural styles or technologies and stuff like that. So I decided to build an application, both as a monolith and then as in the microservices fashion, and see how this works, right? And what kind of things do I run into? So I'll show you the application first. I'm not going to claim it's the coolest application ever, but I, as a developer advocate, oh, sorry, give me a second. This is going to happen numerous times. All right. So as a developer advocate, I'm presenting often, and I love to get questions from the audience. So that's great and everything, but usually everyone just waits to the end, and sometimes someone might have a question at the beginning and they forget about it, or they're too embarrassed to get up in front of the crowd and ask their question because maybe they think it's kind of silly and they're going to be embarrassed about it, or whatever the reason may be. So I wanted to create some kind of application where people can attend my session, ask me questions, right when they think with them, or without the need for being embarrassed, and I can respond back to them after. So the idea is pretty simple. I'll start from the beginning here. You log in, and this login is going to be quite unimpressive, but it uses your Facebook account to log in. I've already logged in, so it's my Facebook account, so you don't really see that. But once you log in, basically what you do as a person who's presenting, you go to manage, and you say, I'm going to create a session. And everyone can go to this app. It's called, you can go to sessionqa.com. You'll see the app running. You enter some details about the session. So we'll do this one. So Microservices is the name of the session. The presenter is Ryan Baxter. The event is Devnexus. And the date is today. Now there's two ways to ask questions. You can either go to the app itself, pick the session you're attending, and ask a question through the app. Or I thought it'd be really cool because everyone has mobile phones that they could text in questions, right? So I use Twilio to actually allow people to text in questions. So if they text a message to this phone number here, which I've purchased in Twilio, you'll be able to text in a question as well. So you can save this, and now as the person who created the session, you can see it here, and I can see all incoming questions that are happening, right? So as a user, I can go to the app itself. Try to get both of these things open at the same time here. Let me just refresh the page. So I see, okay, there's this microservices session happening. This is the one I'm at. I'm going to ask Ryan a question. So I'm going to enter my email address. And then I'm going to ask my question. It says, what is microservices? Okay. And I submit it. And you see, as the person who created the session, that comes up automatically, right? I can even text a question as well. So I'm just going to use Google Voice here so everyone can see that. So here's the number, and I'm going to say, when do I make the move to microservices? Okay, and you can send in text messages as well, and that shows up there too. Okay, so now as the person, at the end of the session or whatever, I can go ahead and respond back and say, pay attention to the slides. Oops, that's not a question. And they'll get a response back via email, and this person who sent it in via text will get a response back via text. When you figure it out, let me know. All right, and the sorry, I can't hear you say. No, you can send a text message if you want. The number is, I'll make it bigger here. If you, there. That's the number right there. 617-405-3018. Yeah, see, it's right there. Yeah, so my reply back should show up here in Google Voice, so you can see. Yeah, it does when you text a question, it automatically says thanks for submitting, just to automatically let you know that you got it. But then when I respond back, you see it here. Okay. Cool. So that's the application. That's the basic idea of the application, right? And I said I built this as a monolith and then as a microservice. So I'll show you what it looked like as a monolith first. We're going to lose the projector again. This is extremely annoying. Apologize. Okay. So this is what this looked like as a monolith, right? It's your typical application architecture diagram. I'm sure everyone's monolith kind of looks something similar. I built this app in Java. It deployed as a WAR file. Inside that WAR file, there was some client-side code for the web interface, and then there was some REST APIs. I had CRUD APIs for creating, reading, and deleting sessions, and then I had some CRUD APIs for creating and reading and deleting questions. And then I had some integration with Twilio, and I used SendGrid to send the email responses back. So Twilio was for texting in and replying back via text, and then SendGrid was for replying back via email. And then I had a database tier. It was a SQL database. Everything was stored in the SQL database, right? This is pretty typical, okay? So when I thought about how this application would work in a cloud, I started to think about some different things, right? The first thing I thought about was failure, right? I wanted to be able to deal with failure. So say something happens with the sessions component of this application, right? Maybe it doesn't even crash. Maybe it's eating up 100% of the CPU. How does this affect the rest of my application? Well, I'm sure you guys all have experienced this in some way. Basically, the rest of the application is completely useless, right? Incoming requests from browsers are going to just never get responses back. People sending in text messages, or they won't get responses back because that all happens over HTTP. The app's pretty much dead at this point. Everything about it is gone. So it doesn't even necessarily have to be a crash. It could just be something's going terribly wrong with the sessions component. It's eating up too much of the CPU, and you're still hosed. So that's one problem. I also thought about scaling, right? Granted, my app is probably not going to get the popularity of Facebook, but it's good to think about these things as a developer. Anyways, if for whatever reason I did have a huge amount of load on a portion of my application, what would that be like? So take the Sessions API again. For whatever reason, the Sessions API was getting hit a crap ton, right? And I need to deal with the load in the cloud, so I'm going to scale horizontally because it's cheaper. When I scale, it looks something like this. Not the prettiest diagram, but it looks something like this. But basically, the idea is that I had to duplicate the entire application and deploy the entire application, even though only one component of that application really needed to be scaled. So the problem here is that this is actually more expensive, right? Because the resources required to run the entire application are greater than if I just needed to scale my Sessions API, right? Because that's a much smaller piece of my app. So I have this problem when I go to scale that everything's really scaling everything, even though not everything needs to be scaled. So what I did was I refactored the application in microservices, in a microservices architecture. So when I did that, it looked something like this, right? And basically you can map these light blue boxes here roughly to these dark blue boxes here. And each one of the dark blue boxes is actually its own application running independently of each other, of the others. So I have a client-side code app, a sessions service, and a question service. Now the reply service, I did something a little bit unique here, right? The other thing I thought about here was it would be nice to have when someone replies back to something, to be able to put those things in a queue, right? Because for example, at the end of the 10:30 or 11:45, when all the sessions get out, everyone might be going back and hammering on the reply service, and it might get really loaded, really overloaded. But if I'm just sticking these things in a queue so they can be processed later, the reply service can handle much more load that way. The other thing is that I can now scale these other two workers that are sending the SMS messages and sending the email messages up and down. So I can say, hey, I need 50 more SendGrid services because I have a whole bunch of emails to process, and I can scale that up, and now I have 50 workers going off and taking things off the queue and doing that stuff. The other cool thing about this architecture here, this change, is that if the session service, or I'm touching my microphone, the session service or any of these services die, the rest of the app still works, right? Even down to the reply stuff. So if the Twilio service goes down for whatever reason, and I'm no longer sending out text messages, that's even still okay because I still have these things sitting in the queue. And when the service comes back up, actually everything will just keep on going as it normally did. So there's really some nice failure built into this application, and we'll see this live in a second. Now the other big change that you'll notice here is that I now have two databases, where before I had one, right? So I followed the rule about each service should store data into its own database. So the session service has its own database for storing data about sessions, and the question service has its own database for storing data about questions. Now, this architecture actually isn't perfect. No architecture is perfect, but this one has its issues that I noticed right away. The first happened to do with the client. So the client needs to know about all these services, right? Because it now needs to talk to all these services, and that involves, in the easiest way, right? The client needs to know about all these different URLs to these services. Now, one of the cool things about microservices is that they should be able to evolve independently of each other without affecting anyone. But the fact that the clients all know about these services and have URLs and are calling these URLs directly to these services limits my ability to evolve them. Because say I need to split the session service into two. Well, that requires me to go back to my clients and change that. Or say I need to scale the session service up. The clients have no idea about the second instance about it, the session service. So how do I reduce this fragility between clients and services? Well, a very common pattern in microservices is to introduce something called an API gateway. So the API gateway is, think of it as your public API now, right? The other problem about this previous diagram here is that if you do have a public API, that's you certainly don't want them talking directly to the services, right? Because you're certainly going to break people that way. So an API gateway is a perfect fix for this, right? The API gateway kind of provides me with this well-known concrete interface for my clients, and they can use that, and I can continue to evolve my services independently of my clients without breaking anyone. Now there is some, you do tie the services a little bit to the API gateway. So for example, if I end up splitting the session service into two different services, I do need to tell the API gateway about that, but still my clients remain unaffected because the API my clients are using can work with the API gateway. The API gateway can now call the two services instead of the one service. You can see here, I also, since the client-side code is so tied to the API gateway, I've moved my client-side code into my API gateway application, right? The API gateway is actually just another app in my case. So that's just one minor change I made there. Now, I still have a problem dealing with scaling though, right? If I scale the session service, I really don't want to have to tell my API gateway that there's now two instances about it, right? I don't have to make changes to that. Because I really want to be able to scale dynamically and not have to really deal with any of this stuff. And here's a small little picture about that, right? So if I scale the session service and I have two instances of that thing running, I need to somehow tell the API gateway that, hey, there's this new session service there, and not only do I need to tell the API gateway, but what about the other services that are talking to the session service, right? For example, it's not illustrated here very well in the diagram, but the question service talks to the session service. But the question service still only knows about this one session service. It doesn't know about there's 2, 3, 4, 5 different instances. So to solve this problem, if I go the right way, to solve this problem, we introduced something called a service discovery service. The way this works is basically all your services now talk to the service discovery service. I really hate saying service discovery service. It's really weird. But you know, all the services talk to the service, and they tell them about its existence. So the service discovery service has a complete list of all the services that are running. And this means that, and not only does it tell us the service about it, but it also gives the other services back a list of all the services it knows about. So this has the benefit of communication between services no longer has to be via URL, right? So when I refer to a service, I can just say, I need to call this API that exists in the session service. So I'm going to go to the information I got from the service discovery service and say, tell me all the URLs you know about the session service, and it will give me back a list of URLs that I can use to talk to the session service. Once I have that list, I can then go ahead and make my API calls. This allows me to scale things up, right? So as I scale up, other instances of the session service will register itself with the service discovery service. Does someone have a question back there? Yeah.
So would you normally have like delegation concern? So now the question service knows that there's like 13 others.
Yep.
Is it now responsible for round robining or anything like that? Or
talk about that in a second. Now each service can just refer by a unique identifier. It can refer to each other by unique identifiers, and this allows me to evolve things a lot easier without breaking, you know, less fragility there. Now to your question about kind of round robining things, yes, this now gives you the opportunity to do some kind of client side load balancing. We'll talk about this in a little bit, but there's some libraries out there that you can use that will do some of this client-side load balancing. You can also put a load balancer in front of these services, so you don't have to think about that and let the load balancer deal with the round robining between the scaled instances.
Yeah. Yeah. When you use, I mean, talking about cloud stuff, whether it's Rackspace or AWS, when you put an elastic load balancer in front of that or Nginx, something to take care of that. And then furthermore, I guess when we first got here, you had Hystrix up there. That's probably one of the better ones out there.
Yeah, I'm going to talk about that in a second. Yeah. I'm glad you're paying attention, though. Yeah, so this does allow you to deal with load balancing in different ways. You can deal it with the code. You can deal it with infrastructure. You can deal it with many different ways. You know, there's no one rule for how to do it, but you can start doing some load balancing in different ways. Just real quickly on service discovery stuff, there are some open source projects out there that you can use to build service discovery. It's not something you have to build from scratch. Eureka is a very nice one from Netflix. It's the one I use. Zookeeper is an Apache project. I haven't used it. In Consul is another project I've heard of. I haven't used that one either. But these are all pieces of software that offer service discovery for you. Now, one final thing I want to talk about, I didn't have a really good way of illustrating this into my diagram. I probably could come up with a way, but I couldn't think of it. I'm not very creative. As circuit breakers, right? Who here has heard of circuit breaker pattern? Okay. For those of you who don't know about it, we'll just cover it real quickly. The term comes from an electrical circuit breaker. It works the same way, but basically it's a very important pattern, especially when you have distributed systems like this. So think about if you have service A, service B, and service C. Okay, service A calls service B calls service C. If something happens with service C, right, for whatever reason, it stops responding in a performant manner to requests, that problem is going to start to trickle up the chain of services. Okay, so you're all of a sudden requests from service B are going to service C and they're not getting responses back, and it's causing service B to start to slow down. And then that in turn is going to start to cause problems with service A. So you can see how this trickling up effect starts to really go up the chain and cause a huge bunch of issues for you. The idea is to introduce circuit breakers, what's called circuit breakers, in between these different services so that if there is a problem with one of the services, you can trip the circuit breaker and stop requests from going to that service, right? So that you stop the trickling up effect, and you also give the opportunity to the service that is having the problem an opportunity to recover with itself, right? So maybe it's under a huge amount of load, and it's just under a huge amount of stress, and 5 minutes later it might be okay again. So you give the service an opportunity to recover, and you stop the potential, trickling up effect of problems up through your application. There's also software out there that implements this pattern, which we'll see in a second, which is Hystrix, which he was mentioning. So back to the demos for a second here. I just want to demo some of these things to you. Now, this is awesome. Oh, look at everyone's texting questions. I hope I remember to go back and respond. Let me just fix my resolution because it seems to go on wonky, and I'll have to go over to the projector again. You should only have to do this one more time. I pushed the wrong button. Or 2 more times. All right. Let's try this again. All right. So my microservices application is actually deployed to Bluemix. So Bluemix, just real quickly, and I don't want to do product pitches, but Bluemix is IBM's platform as a service. Actually, it's a cloud platform. It's not just a platform as a service. It does offer you a platform as a service. You can also deploy apps via Docker containers, if you're familiar with Docker, or you can get a VM or whatever as well. Anyways, I've deployed, and it's the PaaS part of Bluemix is based on top of Cloud Foundry. It's an open source platform as a service. So I've deployed. So if you're familiar with Cloud Foundry, then that should make a lot of sense to you. But basically, I have all my applications here running in Bluemix for the Sessions Questions app. Okay, so there's a couple, 6 or 8 or something like that here. Each one are separate apps. Okay. Now, if I wanted to scale, right? For example, say the email service is under a lot of load, which it probably is not at this point in time. But say it was. If I wanted to scale it up, I can easily go here. Oh, one thing I want to show you before I do that. Let me just show you. I want to show you the service discovery stuff. So like I said, I'm using Eureka. So here you can see in my Eureka instance all the different services that I've registered with Eureka. Okay. So here they're all listed. Here are the URLs to them. So all my different services have a copy of this list and know about the different URLs. So for example, if I want to scale one of these services, we'll scale the email service, for example. I'll add another instance of that and click Save. This will just take a minute for it to spin up its additional instance, so we'll keep on going. We'll come back to this in a second. But eventually we'll see that there's 2 instances of the email service up here. 1 second, can I just get through this? Yeah. The other thing I wanted to demo to you was failure, right? So for example, I'm going to demonstrate a failure here. I don't really know how to make my app crash. I'm sure someone could. But I'm just going to kill the text service for a second. So I'm just going to stop it so it's no longer running. And we'll just really quickly, after it stops itself, just make sure that things are working properly, right? I can still get the list of sessions. I can go in and ask a question still, right? So I can go here and ask a question, submit questions. Oops. Just type some garbage in there. That should work, so we should see that garbage under the list of questions now. There, yeah, there's the garbage there, right? So I can even reply back to these. And actually, I can reply back to these text messages. I'm not going to demonstrate this, but I can reply back to these ones that came in via text. And that will still work because actually the queue is there, right? So they'll just sit in the queue. And once I bring back up the text service, they'll actually go ahead and get responses back, right? So that's kind of a good part of that design, right? But for the most part, my application is still functioning, even though I stopped a component of it, okay? We'll jump back to Eureka here and just check that I do have another instance of my email service. You can see here now there are 2 URLs. So now each service knows that there's actually 2 instances of the email service running, which is kind of cool. And the last thing I wanted to demonstrate real quickly was the circuit breaker stuff. Now this one's a little bit tough to demonstrate, so hopefully I'll get through it. It just takes a lot of time for things to realize that you know, I have to simulate a load, and you know, I have to simulate these failures and stuff like that. So it can be a little bit challenging to demo it, but I'll try it anyways. Oops, that's not what I want. So I'm going to use Hystrix, which I'll talk about Hystrix in more detail in a second. This is the circuit breaker implementation from Netflix. So you can monitor different circuit breakers you have in your application. This is actually monitoring my API gateway. So there's circuit breakers at my API gateway that for all the services it talks to. So you can, it will show you requests that are coming in. The green number basically means successful requests that are going through the circuit breaker. Red numbers mean failure requests that didn't successfully go through the circuit breaker. And then blue requests will start showing up once the circuit breaker gets tripped. So I'm going to use a little command line utility to called Siege that will make requests to an API and just put a little bit of load on here so we can see some of the stuff happening. See, okay, the number's going up, right? You know, there's a lot of requests going through, so they're successful. But if I go ahead and kill one of my services, we should eventually, hopefully if things cooperate, we should eventually start seeing some failures and get the circuit to trip. So I'll stop this service here in my app, and we'll see some things happen maybe eventually. Usually stopping things is not the problem. Yeah. Yep. All right. Stopping should happen instantaneously. There we go. So eventually, we will start to see some bad stuff going on once Eureka figures out that. So what happens with Eureka? There's this, there's like this, you know, pinging thing that goes on saying, "Hey, the service is live. The service is live." It happens so often, and once Eureka figures out, "Oh, the service is not there," you'll start to see this number go red. Like I said, it can be a little finicky about time and requests and all this. What's that? Yeah, and I'm not sure what I have it set to right now either, which is another good question. If I made it shorter, it probably would have been better. There we go. We start to see some 500s. So there we see the red number going up here, and now the circuit is turned to open. Now you see the blue number going up. So these requests aren't actually going through. So now I'll just go ahead and start this thing back up, and then we'll come back to this, and hopefully by the end of the session, I have a couple more slides. We'll see it come back open again.
So what's happening then when the circuit's tripped? It's just
it's giving me, yeah. So you can actually do some intelligent stuff here with Hystrix. Actually, you can define a default response that comes back when the circuit gets tripped, right? Maybe you come back with some meaningful error message or whatever, right? Right now, I haven't done that. I haven't actually done the proper thing there, so it's just giving back a 500. But it's
terminating it.
Yeah, it's not actually trying to make the request out through the API gateway anymore. It's stopping right at the API gateway.
The client is not making the call, and the client has got a retry logic. And you've got two APIs that you implement for Hystrix on the client. One of them is what you do on a retry and what you do when it's restored.
Yeah. You'll see the failure number every once in a while. Some of them go through, right? That's Hystrix just allowing a couple through to see if it actually succeeds or not. And eventually that will start succeeding and it will come back, and this circuit will trip. All right, back to the slides, and hopefully I probably gonna have to push that button for the last time. Yep. I'll start paying people to do this. I have a bunch of t-shirts at the booth if you want t-shirts. All right. So a couple more slides, just on a little bit of tooling around microservices. So I feel like every session, who here knows about Docker? All right, I feel like every session needs to talk about Docker, or else you're not cool. So I'm going to make myself cool here. Actually, no, seriously, I think Docker has a great use case in the microservices space because you want to isolate. So if you don't know what Docker is, it's a Linux container, and these Linux containers are kind of like very lightweight, easy VMs. Think of them like that. That's the shortest definition I'll give, but it's not really like that. But anyways, you want this isolation of between all your services. So Docker containers or Linux containers in general are just really good at providing that isolation anyways, right? So you can spin up all these, put each microservice in a Docker container or any Linux container, and have them running on a single machine or across different machines, and deploy your microservices that way. So it's a really great tool for that, right? The problem is, if you're familiar with Docker, is that when you have potentially hundreds of microservices, that means you have potentially hundreds of Docker containers, and that means you have a big management problem on your hands, right? So Docker out of the box doesn't have all these management tools to manage the containers, scale the containers, monitor the containers. And this is starting to change, right? There's starting to be tools out there like Kubernetes and Clocker that are starting to change this space and really go into the management of your Docker containers. But you need to use one of these tools in a real microservices application. When you have one application, one monolith, packaging it in a Docker container and running that Docker container is really simple. When you have hundreds of Docker containers, it's a little bit more challenging. So for that reason, and I'm a little biased, I would fully admit that, I really like platform as a service for microservices, because the platform itself provides all the management stuff that you're missing in Docker, right? And actually, when we're talking about Cloud Foundry, and again, I'm biased to this, we're already using Linux containers. So actually, when you deploy an application to a Cloud Foundry-based platform as a service, what happens under the covers is your application runs inside a Linux container. It's not Docker at the moment, but it runs in a Linux container. It's completely isolated on a machine with other applications. So all that Docker stuff that you have to deal with by yourself is already taken care of by the platform as a service. So I really find platform as a service a really cool tool for microservice-based applications. You can do things like scaling. It has built-in monitoring. So if my application dies, it will automatically restart itself. All this stuff goes a long way as far as less that you have to do. I think deployments are a little bit easier in my mind because with Docker at least you have to define this Docker file and create this Docker file and maintain that thing. With a platform as a service, you just say, here's my WAR file, go ahead and deploy it for me. And you don't have to define this Docker file. With Cloud Foundry, deploying microservices is super easy. I've actually gone through the process of doing this with a Jenkins server. So when I do a commit to any of the services from my microservice-based application, the deployment of that service right after the commit is all automated for me. Right? I automated the whole thing via Jenkins. With Cloud Foundry, you have this nice command line utility which you can easily script. There's also plugins for Maven and Gradle which can also do deployments. You can do things called blue-green deployments, so you can deploy your applications so there's zero downtime, right? So you can deploy one version, have two versions of your app running, make sure the new version's working, and then flip the switch, and now all your traffic's going over to this new version. That's also very easy to do, and actually I automated it completely in my deployments with Cloud Foundry. There is your applications, each application you deploy in Cloud Foundry gets a built-in load balancer from it, right? So you can deal with some of these round-robin concerns we were talking about before. Don't necessarily have to do it in your code. So there's a lot of benefits here to doing stuff with microservices either with a PaaS or even better with a PaaS like Cloud Foundry. So I've mentioned Netflix a couple times. So Netflix is like the poster child for microservices. They're probably not the first people to do it, but they are the ones who popularized it because they said openly, this is what we're doing. And when they went to do it, they actually, they ran into all these problems, right? It was hard to do, it was hard to implement. And they came up with all these tools, for doing their own microservices architecture. And being the good developers, they open sourced it on GitHub. So there's the Netflix open source software, OSS is what they call it. It's a project up on GitHub, and all the things that they do around for microservices is up there, right? They have service discovery, they have circuit breakers, which we looked at with Hystrix. They have something called Ribbon and Feign, which does some of that client-side load balancing with service discovery mixed in, which is really cool. And they have much more, right, that I actually haven't even played around with. Are there any Spring users in the house? Okay, cool. So if you haven't heard about this project from the Spring folks called Spring Cloud, is Spencer Gibb in the room? Spencer in here? Oh, I'm going to yell at him. So Spencer Gibb and Dave Sire from Pivotal worked on the Spring Cloud project. And what they basically did was took all the Netflix open source stuff and created some Spring projects around it, right? And I actually used this in my application. Spencer is giving a talk right after mine, I think, on this. And I highly suggest you go to his talk because this stuff is super easy to use. They've put a lot of thought into it. They just did the 1.0 release last week or something like that. So if you're a Spring user and you're interested in microservices and you're already using Spring Boot, the first step is to use Spring Boot. The second step is to use Spring Cloud. And then you should definitely check out his talk right after mine. It's really cool. And the last slide I have is just about everyone's question about when do I make the switch to microservices. I don't have the answer to this. I don't pretend to know the answer to it. It's dependent on your team, what your team thinks. Are you at the point where you want to make the switch to microservices? I don't know. I've heard a lot of different theories about how to do it. Some people say take the most well-known portion of your monolith application and start there and start factoring that stuff out into microservices. Other folks say take the piece that causes the most pain in your application and factor that out into microservices, because then you get you can prove to the naysayers that, hey, look at all these benefits we got by doing this, right? And there's no longer all this pain that we had before. And some people say, well, we're actually going to ignore the monolith right now, and all the new features we add, we're just going to add as microservices on top of the monolith, right? So they still have the problem with the monolith there, but they're demonstrating the fact that microservices work, and hopefully they can then convince the powers to be that they can go back and refactor the monolith to do the same thing, so they get the ultimate flexibility that they're looking for. So you can Google this and read a whole bunch of articles about people who have done it. People, techniques they had and the pains they went through. But this really is the million-dollar question with microservices. When do you make the switch and what does that cost? So with that, I'll say thank you and ask any questions. Everyone has any questions, that would be cool. That's it.
So most of what I've read is talk about these vertical lines when you talk about microservices. What are your thoughts around having the client and the database still a monolith, and then are there any benefits of still having, getting towards microservices type architecture for the middle layer? Because I think the client and the database sometimes is out of our control. I mean, it's not something.
Yeah, and I think that this goes back, saying that it's out of your control, this goes back to changing the way your organization works first, right? Because if you have an organizational structure where the team that owns the service is responsible for the entire thing, including the client-side stuff and the database all the way through, then that's not really a problem. You can't make this claim that it's out of my control. But I think, to the last slide about transitioning to microservices or getting started in microservices, there needs to be a starting point somewhere, and maybe for you it is that middle layer, and eventually you prove the worth of microservices, and then start to go back. You convince your organization that okay, it's time to actually do the proper way and change the client side, change the database layer as well. But yeah, it could be one technique. Yeah. Question in the back?
Yeah. What kind of endpoints do you use most commonly for microservices, and what kind of communication protocols do you use?
I've found that I think the most common is always HTTP and REST and JSON, right? I think that's probably the most common. And I suggest that's where you start out from and see if that works. Another common technique for communication is to use message queues where it makes sense and do asynchronous communication that way. That can get a little challenging though. It's a little bit more challenging than HTTP and REST. But those are the two most popular ones that I've heard of. Yep.
You use Facebook for authentication.
Yep.
Do you have like suggestions for how to use authentication as a service itself, or how like is there a pattern for authentication?
Yeah. So part of the Spring Cloud library includes this SSO stuff, and that's what I'm using there. Recently, I've come across a service called Auth0, AUTH0. You go to auth0.com. They do authentication as a service, and it's super cool. I haven't played around with it enough to actually put it into my application, but they have a whole bunch of different options for authentication, including all the social services. You can connect to LDAP servers and Active Directory servers and whatever you want. Yeah, you should take a look at that. Auth0, AUTH0. Yeah. One question?
Does it have to have compliance issues like HIPAA or PCI, and where DevOps is already a challenge because for compliance you can't have your developers in your production systems. Have you worked with anything where you've had to deal with that?
I haven't personally had to deal with that. I mean, I'm not familiar with all the compliance concerns around that either, so it's hard for me to speak to it, but I mean, you can definitely separate out, you know, I'm sure you probably do this today, separate out, you know, what development does and where they deploy to, and then have people who are able to do the deployment to production. I mean, that can all be automated. I'm not, we could talk after. I'm not familiar enough with the compliance concerns you're talking about to really make a comment on it. All right, I don't know. I think I'm getting kicked out. But